Okay, so let's finish going over the examples from class today. So we want to look at this graph and we want to write an equation of this piecewise function. So we started looking at this left branch here, and I believe we said that the slope was 1 and the y-intercept was also 1. So our equation over here would be x plus 1, and our x value here would be a positive 3. So this line is basically saying that we have all x values less than positive 3. And it's just less than because this is an open circle here. Excuse me. So for the next part, I'm actually going to look at this point right here, and I'm going to also make sure that I include this in my piecewise function. And this will be pretty similar to one of the graphing examples that we looked at. Whenever you see a point, this is basically saying that this is a y value of 6 when x is 3. So the way that we would write that in our piecewise function is we would say f of x is equal to 6, comma, x is equal to 3. So this is saying f of x, or y, is equal to 6 when x is equal to 3. And then I'll go ahead and take a look at this last branch of the graph over here on the right. So we should be noticing that this is a horizontal line, and equations of horizontal lines are just whatever that y value is, because remember that the slope here is 0. And our y value is 1. Again, that would be our y-intercept if we were to kind of continue the graph along and go back to the y-axis. So that would tell me that this function, if I write it in slope-intercept form, y would be equal to 0x plus 1. And again, I could just write that simpler and say that it's y is equal to 1. So over here in my piecewise, I'm going to say f of x is equal to 1, and that's when x is anything bigger than 3. So x is greater than 3. So that would be our piecewise function for our first example. All right, so the next one, I'm going to show you how to write this a couple different ways. I'll show you kind of just taking it apart and writing it in its linear pieces first, and then I'll go back and I will show you how to look at this piece a little bit differently and relate it back to what we've been doing the last couple of weeks. So here, I'm going to go ahead and set up my piecewise. And if I'm just doing in the linear pieces, I really have 4 linear pieces here. I have this kind of like left upper branch. I'm going to break this down into this piece right here, this piece right here, and then this upper right branch. So my first piecewise that I'm going to write is actually going to have 4 parts to it. So my first line over here actually has a slope of -1. And if I were to continue to kind of extend this line towards the y-axis, I would see that my b value, or my y-intercept, would be 0. So I'm actually just going to write this as negative x, because if I write it as an equation of a line, that would be -1x plus 0. So I'm just going to make it a little bit simpler and say that's just negative x. And that's for any x value less than -4, because that's the x value here where my open circle is. And it's just less than because of the open circle. And then I'm going to take a look at this piece here. So from here to here, I have another piece of my graph. So this piece has a slope of 1, and it would also have a y-intercept of 0. So if I write that in slope-intercept form, that would be y is equal to 1x plus 0, which just in a little bit simpler form would just be y is equal to x. So y is going to be equal to x. And here I have a starting point and I have a stopping point. So my starting point is -4. My stopping point is 0. My x is going to be somewhere in between there. And since I do have a closed dot here, I want to make sure that I'm using the equals to symbol in my inequality. And there's a couple different ways that you can take care of this point. I'm going to include it in this first equation. You could not include it in this first equation and just make sure it's included in the next equation. But we'll talk about that in one second, and I'll show you how you could also write that. But let's take a look at the equation of this piece here. So from here to here, I've got this little line segment here. So its slope is -1. Its y-intercept is still 0. So if I were to write this in slope-intercept form, y would be equal to -1x plus 0. I'm going to go ahead and I'm going to write that as just -x here. And that's from the x value of 0 to the x value of 2. So x is going to be somewhere in between 0 and 2. But the thing is here is when you're writing the equation of piecewise functions that meet at a point, you have to make sure that your point that's kind of shared between the two line segments is included in one but not included in the other. If you include it in both, that would just mean that it wouldn't pass the vertical line test and it wouldn't be a function. So I'm going to choose to include it here and not here, but that could also be swapped. You could choose to not include it here and just include it here. It really doesn't make a difference. But here I do want to include the 2 since that is a closed dot. So I'm going to make sure I use the less than or equal to symbol here. And then my last piece over here is going to be kind of this upper right branch. So I'm going to say its slope is also a positive 1. And if I were to continue this line down to the y-axis, its y-intercept would be a -1. So I'm going to write that as y is equal to x minus 1. And that's going to be for any x value greater than 2. And it's just going to be greater than because of the open circle here. So x greater than 2. So you could also, like I was saying before, kind of play around with these less than and less than and equal to symbols. So another correct way to write this would just be negative x when x is less than -4, x when -4 is less than or equal to x or less than 0. So here, instead of including like we did up here, we're not including it here. And then we would just want to make sure that if we were going to do that, we would include it in the next inequality. So not included here and included here would be definitely okay. And then x minus 1 when x is greater than 2. So that would be kind of what our possible piecewise functions would look like if we were just taking these into linear pieces. We can actually make this a little bit simpler and kind of get rid of these 2 middle pieces by actually turning this piece into an absolute value function. So another possibility for writing this equation of the piecewise function would still be to keep the first and the last equations exactly the same. So the -x when x is less than -4 and the x minus 1 when x is greater than 2 would still be the same because these 2 pieces on the ends really like aren't changing, like this one over here and this one over here. But what we could do is we could actually say that this is an absolute value graph that's been reflected. And the reason for that is because we have this upside down V shape. And we know that the relationship between the slope of the right branch and the slope of the left branch is that one of them is going to be the positive value and one of them is going to be the negative value. So if we take a look, we're seeing that there's that relationship here. As long as these slopes are the same numerical value and then one of them is either positive or one is negative, we know that this could actually be part of an absolute value graph. So there wouldn't be any transformations in terms of a stretch or a shrink because we know that the A value would be 1 or -1 in this case since it's reflected. We're not moving up or down or left or right. So we know there's not going to be any sort of horizontal or vertical translation. So what we could say is we could actually call the equation of this V right here, y is equal to the negative absolute value of x. So I could write it as negative absolute value of x when x is falling in between -4 and +2. And both of these values would be included since these endpoints are closed circles. So just so that you know, if you do recognize that you have like a slope of +1 here and a slope of -1 here, that could actually be turned into an absolute value function. So there's really 3 different ways that you could potentially write the equation of this piecewise function. So any one of these 3 would be fine. All right, so I will let you guys practice on your homework. Please let me know if you have any questions.